Good afternoon, students. So let us start with today's class, that is magnetism and matter. In the first class, we have discussed about the properties of the magnets. What do you mean by magnet anta nodidvi? What are the properties of the magnet we have discussed? What is magnetic field? Magnetic field lines andre enanta nodidvi. Yes. Then after that, we have discussed about the magnetic field lines properties. Then today we are discussing about the magnetic dipole and the Gauss law. These 2 points we are discussing. As I told you, the lesson is very small, and again in that some parts it is deleted. So ಹಾಗಾದ್ರೆ ಈಗ ನಾವು ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ from the magnetic dipole ಇಂದ. So what do you mean by the magnetic dipole? The magnetic dipole is nothing but here it is defined as pair of a pair of two unlike the poles of the same strength are separated by some distance is called as what? Magnetic dipole anta heltivi. So the magnetic dipole is denoted by the letter M. How you can define? This is magnetic dipole moment. Okay, idanna magnetic dipole moment anta heltivi. Yav ರೀತಿಯಾಗಿ ನೀವು magnetic dipole ಅನ್ನ define ಮಾಡಬಹುದು ಅಂತ ಅಂದ್ರೆ you can define it. It is a pair of two. It is a pair of two unlike magnetic poles. It is a pair of unlike magnetic poles of equal pole strength. Equal pole strength ಅನ್ನ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? That is magnetic dipole ಅಂತ ಹೇಳ್ತೀವಿ. How you define the electric dipole? That is the two unlike charges are separated by some distance is called as the electric dipole. ಅದೇ ರೀತಿಯಾಗಿ magnetic dipole ಅನ್ನ the two magnetic poles are separated by some distance of the same strength are called as what? Magnetic dipole. The magnetic dipole moment, in the last class I told you what is the expression for the magnetic dipole moment. The magnetic dipole moment is given by capital M is equal to M into 2L. So 2L ಅನ್ನೋದು dipole length ಆಗುತ್ತೆ, M ಅನ್ನೋದು pole strength ಆಗುತ್ತೆ. Yes. So now what we are going to discuss anta andre, here we are discussing some of the equations only, because the derivation again it is a deleted here. So suppose if you are having a dipole, okay, so ನಿಮ್ಮ ಹತ್ರ dipole ಇದೆ, ಅದನ್ನ ನೀವು ಎಲ್ಲಿ ಇಡ್ತಾ ಇದ್ದೀರಾ? You are placing a dipole in the external magnetic field. So I am placing a dipole in the external magnetic field. So in that case we are writing some of the equations for that. So this is north pole, this is south pole, this is my magnetic dipole. Aita, it is in the magnetic field B. So ivaga we are writing. So as you know that any dipole is placed in the magnetic field or electric field, what it will experience? Idರಲ್ಲಿ ಏನು experience ಆಗುತ್ತೆ? It will experience a torque ಅಂತ ನಮಗೆ ಗೊತ್ತಿದೆ, ಹೌದಾ? So the body will experience a torque when it is placed in the field, because the two unequal forces are acting, two equal magnitude but opposite direction. The torques are acting on that. Therefore, the torque is given by, you can take the direct formula for the torque experienced by the dipole in a magnetic field. So the torque is given by, that is mb sin theta. So this is the torque expression, the restoring torque anta helbodu. It is given by mb sin theta. M is mass, B is the magnetic field. Okay. So here in this derivation we come across ಇದು ಈ derivation ಅಲ್ಲಿ ಮತ್ತೊಂದು 2-3 formulas ಬರುತ್ತೆ, ಅದನ್ನ ಕೂಡ list out ಮಾಡ್ಕೊಳ್ಳಿ. The magnetic field for this is given by, the magnetic field is equal to 4t square into I divided by m into t raised to 2. 4 pi square I divided by m into t square, where I is the moment of inertia. Okay, I ಅಂದ್ರೆ moment of inertia ಬರುತ್ತೆ. 4 pi I divided by m t square. T is the time period. So therefore the equation, if you write it for the time period, please note down the formula for time period equation and modify madidre root of 4 pi square into I divided by mb anta barutte. This is the time period. Similarly, the frequency is written as, frequency is equal to 1 upon 2 pi under root of mb divided by I. The frequency is given by 1 upon 2 pi under root of mb divided by I. Yes. So frequency, time period, torque, magnetic field. Please take down all the formulas here. Similarly, we can write the angular frequency formula also, students. So angular frequency is given by omega is equal to root of mb divided by I. Yes, the terms are having the usual meaning. If you don't know any term here, please ask. ಮತ್ತೆ ಇಲ್ಲಿ potential energy of the dipole. So the potential energy expression for that, the energy stored in the dipole, it is given by the potential energy equation is minus mb cos theta, minus mb cos theta. So please write down all the formulas. If you don't know any term here, please ask. So torque, magnetic field, time period, frequency, angular frequency, and the potential energy of the dipole. M is magnetic moment, okay? It is not mass, it is magnetic moment. M is magnetic moment in all the equation. So ನೀವು mass ಅಂತ ಹೇಳ್ಬಿಟ್ರೆ wrong ಆಗತ್ತೆ. M is the magnetic moment. So if magnetic moment term is not there, ಅದು dipole ಅಂತ ನಮ್ಗೆ ಅರ್ಥ ಆಗಲ್ಲ, ಹೌದಾ? So last lesson ಅಲ್ಲಿ ಒಂದು derivation ಇತ್ತು ನೋಡಿ. Yes, completed both of you. If completed, I can tell you the next one. So next we need to understand when the potential energy is maximum minimum, because already you know cos theta ಯಾವಾಗ maximum ಇರುತ್ತೆ minimum ಇರುತ್ತೆ ನಿಮಗೆ conditions ಗೊತ್ತಿದೆ. Just for the understanding I am just telling you once again. So here the expression for the potential energy we have written it as what? U is equal to minus mb cos theta. ಹಾಗಾದ್ರೆ ಇದರಲ್ಲಿ what we are learning when this potential energy will be maximum and minimum. So if I take the case 1, when you consider the theta is equal to 0 degree, so cos 0 will be 1, cos 0 will be, it is 1, therefore u is equal to minus mb anta agutte, u is equal to minus mb anta barutte, which means that it is minimum potential energy, it is the minimum potential energy. So case 2 if I take, when theta is equal to 180 degree, when theta is equal to 180 degree, in that case u is equal to mb anta barutte, this is the maximum potential energy, it is the maximum potential energy. This similarly third case, if we take theta is equal to 90 degree, so theta is equal to 90 degree means that is cos 90, so cos 90 means u is equal to 0, so which means that it is 0 potential energy. So maximum potential energy, minimum potential energy, 0 potential energy. So in 1 mark or in the fill in the blanks athwa MCQs alla barutte, so please take down this. So if this is completed, we can see the Gauss law in magnetism. Okay, so let us see what is Gauss law in the magnetism. So already you have studied the Gauss law in electrostatics. So what is Gauss law in electrostatic? You remember that is the the electric flux is equal to 1 upon epsilon naught times the total charge enclosed by the system. This is called as what? The Gauss law in electrostatic. Idu Gauss law in electrostatic ಆಯ್ತು. ಈಗ ನಾವೇನ್ ಮಾಡ್ತಾ ಇದೀವಿ? Gauss law in magnetism we are deriving. So ನಿಮ್ಗೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಗಾಸ್ ಲಾ ಕೇಳಿದ್ರೆ ಯು ಕ್ಯಾನ್ ರೈಟ್ ದ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಗಾಸ್ ಲಾ ಬರಿಬಹುದು, ಅಥವಾ ಸ್ಪೆಸಿಫೈ ಮಾಡಿ ಅವರು ಏನಾದ್ರು ಗಾಸ್ ಲಾ ಇನ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಕೇಳಿದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ರೈಟ್ ದಿಸ್ ಸ್ಟೇಟ್ಮೆಂಟ್. ಸೊ ಸಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ವಾಟ್ ಇಸ್ ದ ಗಾಸ್ ಲಾ ಇನ್ ದಿಸ್ ಒನ್? ದ ಗಾಸ್ ಲಾ ಇನ್ ದ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ is given by, it is the net magnetic flux through any closed surface. The net magnetic flux through any closed surface is ಆಲ್ವೇಸ್ ಝೀರೋ ಅಂತ ಹೇಳ್ತಾರೆ. ಸೊ ದ ನೆಟ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಥ್ರೂ ಎನಿ ಕ್ಲೋಸ್ಡ್ ಸರ್ಫೇಸ್ ಇಸ್ ಆಲ್ವೇಸ್ ಝೀರೋ. ಸೊ ಇದ್ರ ಮೀನಿಂಗ್ ಏನಾಗತ್ತೆ, ಇಲ್ಲ ನಾನು ಫಸ್ಟ್ ಮೆಥಮೆಟಿಕಲಿ ಏನಂತ ಬರೀತೀನಿ. ಸೊ ದಿಸ್ ಇಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್, ಪೈ ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. The magnetic flux is given by, that is BDS is equal to 0. These are the vector quantities. Okay, so suppose ನೀವು ಈಗ ಏನಾದ್ರೂ ಒಂದು ಸರ್ಫೇಸ್ ಅನ್ನ ಕನ್ಸಿಡರ್ ಮಾಡಿ ಸ್ಟೂಡೆಂಟ್ಸ್ ಇಲ್ಲಿ. ಸೊ ಕನ್ಸಿಡರ್ ಎ ಕ್ಲೋಸ್ಡ್ ಸರ್ಫೇಸ್. ಸೊ ಕನ್ಸಿಡರ್ ಒನ್ ಕ್ಲೋಸ್ಡ್ ಸರ್ಫೇಸ್. ಸೊ ಇದೊಂದು ಎಸ್ ಸರ್ಫೇಸ್ ಅಂತ ತಗೊಂಡ್ರೆ ನೀವು ಇಲ್ಲಿ ಇದ್ರದ್ದು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಬಿ ಅಂತ ಇದೆ. ಸೊ ಕನ್ಸಿಡರ್ ದಿಸ್ ಆಸ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್. So this is the magnetic field B. Okay, so this is the magnetic field B. And here what we are going to consider, in one small area consider ಮಾಡ್ತಾ ಇದ್ದೀನಿ. I am considering one small area. So ಈ area ನ delta S ಅಂತ ತಗೊಳ್ತೀವಿ. Okay, or ds ಅಂತ ಕೂಡ ತಗೊಳ್ಬಹುದು. You can consider this area as what, that is ds. So consider this area as ds. Okay, now here the let theta be the angle between. So ಇಲ್ಲೇನ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ, ಈ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಒಟ್ಟಿಗೆ ನಿಮ್ದು ಇಲ್ಲೇನಿದೆ ಏರಿಯಾ ಏನ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದೀರಾ ಥೀಟಾ ಅಂತ, ಅದ್ರದ್ದು ಆಂಗಲ್ ತಗೊಂಡ್ರೆ ಸೊ ಈ ಬೇಸಿಸ್ ಮೇಲೆ ನಾವು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಅನ್ನ ಡಿಫೈನ್ ಮಾಡ್ತಾ ಇದೀವಿ. ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್ ಇಸ್ ಗಿವನ್ ಬೈ, ದಟ್ ಇಸ್ the BDS is equal to what? It is 0. So the net magnetic flux through any closed surface. ಇದೊಂದು closed surface ಇದೆ. So in the closed surface, the magnetic field will be, the magnetic flux will be 0 ಅಂತ ಹೇಳ್ತಾರೆ. Very simple statement, no complications in this. Yes. So according to electrostatics, so electrostatics ಅಲ್ಲಿ ನಾವು ಏನ್ ಅಂತ ಹೇಳ್ತೀವಿ, the flux is equal to 0 in one case. ಯಾವ ಕೇಸ್ ಅಲ್ಲಿ ಹೇಳಿ, when it is a closed system. So closed system ಇದ್ದಾಗ ಅಥವಾ ಅಲ್ಲಿ ಸರ್ಫೇಸ್ ಒಳಗಡೆ, we know that the charges lie on the surface. charges ಹೊರಗಡೆ ಇರುತ್ತೆ, not inside the body. So inside the body the flux will be 0 according to electrostatics. So according to electrostatics, the flux will be 0 inside the body. Now here suppose if we are considering with respect to the magnetism, illen ಹೇಳ್ತಾ ಇದೀವಿ the flux is 0 for all the closed surface ಅಂತ ಹೇಳ್ತಾ ಇದೀವಿ. ಅಲ್ಲೇನಾಗುತ್ತೆ, the flux value is different. It is what, q divided by epsilon naught when it is considered on the surface. But within the surface ನೀವು ತಗೊಂಡ್ರೆ flux 0 ಅಂತ ಹೇಳ್ತೀವಿ. But magnetic field ಅಲ್ಲಿ, magnetism ಅಲ್ಲಿ the flux is 0 always for the closed surface ಅಂತ ನಾವಿಲ್ಲಿ ಹೇಳ್ತಾ ಇದೀವಿ. Okay. So now after this point what we have discussed till now, here we can compare some of the points students. ಏನ್ ನೋಡಿ, till now we have completed, because last part ಗೆ ಬಂದಿದೀವಿ. ಅಲ್ಲೇನ್ ಕಲಿತೀವಿ, earth magnetism actually delete ಮಾಡಿದ್ದಾರೆ. ಅದನ್ನ ಬಿಟ್ಟು magnetic materials ಅಂತ 3 types of material study ಮಾಡಿದ್ರೆ the lesson is getting over. So now we can just little do comparison with your electrostatic and magnetism. So electrostatics ಅಲ್ಲಿ ನಾವು ಅಲ್ಲಿ ಕೆಲವೊಂದು ಫಾರ್ಮುಲಾನ ಕಲಿತೀವಿ. ದ ಸೇಮ್ ಫಾರ್ಮುಲಾ ಇನ್ ಮ್ಯಾಗ್ನೆಟಿಸಮ್ ಆಲ್ಸೋ ವಿ ಸ್ಟಡಿ. ಏನ್ ಡಿಫ್ರೆನ್ಸ್ ಇದೆ ಅಂತ ನೋಡ್ಕೊಳ್ಳಿ, ಹಾಗಾದ್ರೆ ನಿಮ್ಗೆ ನೆನ್ಪು ಉಳಿಲಿಕ್ಕೆ ಈಸಿ ಆಗತ್ತೆ. ಸೊ ಯು ಕ್ಯಾನ್ ಸಿ ವಾಟ್ ಪಾಯಿಂಟ್ಸ್ ಐ ಆಮ್ ಮೇಕಿಂಗ್ ಹಿಯರ್, which will help you to remember the formula for the long time. So the electric field is denoted by the letter E. The magnetic field is denoted by the letter B. This is electric field, this is magnetic field. ಹೌದಾ? Next, the dipole moment is denoted by their P. ಮತ್ತೆ ಇಲ್ಲಿ dipole moment ಅನ್ನ M ಇಂದ ಡಿನೋಟ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಅಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಏನಂತ ತಗೊಂಡಿದೀವಿ ಸ್ಟೂಡೆಂಟ್ಸ್, ಅಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಅನ್ನ ನಾವು 1/4π ಅಂತ ತಗೊಂಡ್ವಿ ಫಸ್ಟ್ 2 ಲೆಸನ್ಸ್ ಅಲ್ಲಿ. ಮತ್ತೆ ಈಗ 4th 5th ಲೆಸನ್ ಅಲ್ಲಿ the constant is almost we have taken it as what, mu naught upon 4π. ಸೊ ಅಲ್ಲಿ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಅಂದ್ರೆ ಪರ್ಮಿಟಿವಿಟಿ, ಇಲ್ಲಿ ಮ್ಯೂ ನಾಟ್ ಅಂದ್ರೆ ಪರ್ಮಿಯಾಬಿಲಿಟಿ. ಏನ್ ರಿಪ್ಲೇಸ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂತ ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಎಸ್. ಸೊ ನೀವು ಈಗ ಬೇಕಾದ್ರೆ ಎಲ್ಲಾ ಕ್ಲಾಸಲ್ಲಿ ನೋಡಿ, ಫಸ್ಟ್ 2 ಲೆಸನ್ಸ್ ಅಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ಇತ್ತು, ಇಲ್ಲಿ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಇದೆ, ಅಲ್ಲಿ ಇ, ಇಲ್ಲಿ ಬಿ, ಮತ್ತೆ ಅಲ್ಲಿ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಅನ್ನ ಪಿ, ಇಲ್ಲಿ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಅನ್ನ ಎಂ ಇಂದ, ಮತ್ತೆ ಅಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ಸ್ ಅನ್ನ 1/4π ಎಪ್ಸಿಲಾನ್ ನಾಟ್, ಇಲ್ಲಿ ಮ್ಯೂ ನಾಟ್ ಅಪಾನ್ 4π, ಮತ್ತೆ ಪರ್ಮಿಟಿವಿಟಿ ಎಪ್ಸಿಲಾನ್ ನಾಟ್ ಅಂದ್ರೆ, ಮ್ಯೂ ನಾಟ್ ಅಂದ್ರೆ ಪರ್ಮಿಯಾಬಿಲಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ, ಹೌದಾ? ಸೊ ದಿಸ್ ಇಸ್ ಒನ್ ಲೀಸ್ಟ್. ಮತ್ತೊಂದು ಲೀಸ್ಟ್ ಮಾಡಿ. So according to one more list, what we are writing here, the electric field intensity for the dipole, the electric field intensity for the short dipole navenanta baritivi, it is 1/4π epsilon naught p divided by r cube. Matte in case of the magnetic field is given by, it is mu naught upon 4π m divided by r cube, m divided by r cube. Okay, this is the for the equatorial point. ನೀವು ಕಂಪೇರ್ ಮಾಡಬಹುದು. 1/4π epsilon naught ಇದೆ, ಇಲ್ಲಿ mu naught upon 4π ಇದೆ. P by r cube, here it is m by r cube. This is the electric field intensity for the equatorial point. Equatorial point ಗೆ ಎರಡು ಕಡೆ derivations ಅನ್ನ ನೋಡಿದ್ರೆ you can compare this. Along the axial line, the electric field intensity is given by 1/4π epsilon naught 2p divided by r cube. ಮತ್ತೆ ಇಲ್ಲಿ ನೋಡಿದ್ರೆ this is b is equal to mu naught upon 4π 2m divided by r cube. ಹೌದಾ? Next, the torque in the the torque expression for the electrostatics ಅಲ್ಲಿ PE sin theta ಅಂತ ಬರುತ್ತೆ. ಮತ್ತೆ ನೀವು ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಲ್ಲಿ the torque tau is equal to mb sin theta. It is mb sin theta. And the potential energy in case of the electrostatics, it is given by minus PE cos theta. ಮತ್ತೆ ಇಲ್ಲಿ ನೋಡಿದ್ರೆ ನಿಮ್ಗೆ P is equal, U is equal to minus mb cos theta. Yes, why I am giving you this list anta andre, because ಇದನ್ನ ನೀವು list out ಮಾಡಿ ಇಟ್ಕೊಂಡ್ರೆ you can solve here around so many formulas, because ಇಲ್ಲಿ 4 ಇದೆ, ಇಲ್ಲಿ 4 formulas ಇದೆ. ಕಂಪೇರ್ ಮಾಡಿ ನೆನಪಿಟ್ಕೊಳ್ಬಹುದು. Now the lessons are less, you can remember, but once we complete 50% syllabus, 80% syllabus, it is difficult to remember the formulas. So ಈ first four lessons ಅಲ್ಲಿ first 5 actually, but a third lesson ಅದು ಸ್ವಲ್ಪ ಬೇರೆ ಆಗುತ್ತೆ. ಫಸ್ಟ್ ಅಂಡ್ ಥರ್ಡ್, ಫೋರ್ತ್ ಅಂಡ್ ಫಿಫ್ತ್ ಲೆಸನ್ ಸ್ವಲ್ಪ ಕಂಪ್ಯಾರಿಸನ್ ಮಾಡ್ಬೋದು ನಾವಿಲ್ಲಿ. ಗೊತ್ತಾಗ್ತಾ ಇದೆಯಾ? ಯು ಕ್ಯಾನ್ ಸಿ ದ ಕಂಪ್ಯಾರಿಸನ್. ವಿತ್ ಕಂಪ್ಯಾರಿಸನ್ ಯು ಕ್ಯಾನ್ ಟ್ರೈ ಟು ರಿಮೆಂಬರ್, ಸ್ಟೂಡೆಂಟ್ಸ್. So if you want, make a note of this. We will see some next. Okay. Yes. So now we are left with only last part of the lesson. ಅದನ್ನ ನಾಳೆ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ. ಈಗ ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸ್ ಅನ್ನ ನೋಡೋಣ, because I have given you just now so many formulas. So accordingly we will see some questions. So sorry, I don't have the PDF right now. I'll just dictate the question and you solve it. Okay, so take the question, students. Magnetized a magnetized needle of magnetic moment. So magnetic moment value ಕೊಟ್ಟಿದ್ದಾರೆ. It is 4.8 into 10 raised to minus 2 joules per Tesla. 4.8 into 10 raised to minus 2 joules per Tesla. A magnetized needle of magnetic moment 4.8 into 10 raised to minus 2 joules per Tesla is placed at 30 degree with the direction direction of uniform magnetic field of magnitude. So ಇದ್ರದ್ದು magnetic field magnitude ಎಷ್ಟಿದೆ? It is 3 into 10 raised to minus 2 Tesla. What is the torque acting on the body? What is the torque acting on the needle? What is the torque acting on the needle? So see, a magnetized needle of magnetic moment value is given here, students. So magnetic moment andre m value ಕೊಟ್ಟಿದ್ದಾರೆ. It is 4.8 into 10 raised to minus 2 joules per Tesla. Next is placed at the angle of 30 degrees. So theta is equal to it is 30 degree with the direction of the uniform magnetic field of magnitude. So the magnetic field value is given. It is 3 into 10 raised to minus 2 Tesla. Hagadre, what is the torque acting on the body? Yes, you only do this and tell me the answer. In the chat box, you just tell it what is the answer. Because already ನಾನು ನಿಮ್ಗೆಲ್ಲ ಲಿಸ್ಟ್ ಕೊಟ್ಟಿದ್ದೀನಿ ಫಾರ್ಮುಲಾ. Six 6.75 or 7.2. Yes, what you will get here, students? Here the formula is mb sine theta. Howda? So m value is 4.8 into 10 raised to minus 2 into b value. Magnetic field is 3 into 10 raised to minus 2 theta sine 30. Yes. See how much you are getting. Yes, it is 7.2. So if you simplify, you will get it as, check with your answer, you will get it as 7.2 into 10 raised to minus 4 joules. Yes, the next question. Take the next question. The next question is a short bar magnet. Write down a short bar magnet placed placed with its axis at 30 degree to a uniform magnetic field of 0.2 Tesla. A short bar magnet placed with its axis at 30 degree to a uniform magnetic field of 0.2 Tesla. It experiences a torque of torque value ಕೊಟ್ಟಿದ್ದಾರೆ 0.06 Newton meter. It experiences a torque of 0.06 Newton meter. So what all you need to calculate? See, students. First point, calculate the magnetic moment of the magnet. So you need to calculate the magnetic moment. So first calculate magnetic moment. Second, they are asking you potential energy. So the second point, they are asking you to calculate the potential energy. Potential energy when P is minimum. They are asking to calculate the potential energy when potential energy you take it as for minimum. Minimum andre just now I told you when it is maximum, minimum and it is negative. So accordingly you need to calculate that. Yes. So first we need to calculate the magnetic moment. So to calculate the magnetic torque is given, angle is given. So we have the formula, the torque is equal to mb sin theta. ನಮಗ್ ಬೇಕಾಗಿರೋದು magnetic moment. So m is equal to tau divided by b sin theta. So tau value is given, that is 0.06 divided by this is 0.2 into sin 30, which is giving you the magnetic moment C. So calculate here. And potential energy you have to calculate for the minimum angle, that is potential energy is equal to, we know the formula, minus mb cos theta, minus mb cos theta. So minimum andre cos 0 togoli, theta is equal to 0. Yes, 0.6 is the correct answer. So m is 0.6, m value is 0.6. Write the unit also, students. The magnetic moment is given by ampere meter square. It is ampere meter square. So one more formula also you can write. Okay, so that is the magnetic moment is equal to current into area anta kuda navilli tagolbodu ಕೆಲವೊಂದ್ಸಲಿ. Current into area. So the potential energy cos theta is equal to 0. That is nothing but cos 0. Cos 0 is 1. But mb value is given ala. So mb value you can substitute, that is 0.6 into b value is given as 0.2. Yes, answer is 0, correct it is. So for minimum and for minimum means potential energy, we have to take it as 0 only. No need to substitute this, just take it as what? The potential energy is 0 because angle is 0. Theta is equal to 0. No, theta 0, cos 0 baratte. Cos 0 andre 1 agattala. And mb value is given. So substitute the mb value. Yes, what we are doing for the potential energy, it is minus mb cos theta. So cos 0 is 1. Therefore, minus m value is 0.6 into b value is 0.2. Yes, 0.12. Okay. Yes, correct. Minus 0.12 is the answer. The last question, students. A current of 5 ampere. A current of 5 ampere is flowing through a 10 turn circular coil of radius 7 centimeter. The coil lies in the XY plane. The coil lies in the XY plane. What is the magnitude of magnetic dipole moment. What is the magnitude of the magnetic dipole moment associated with it? So see a question, a current of 5 ampere. So the current value is given as how much? It is given as 5 ampere. The current is given as 5 ampere with the number of turns, 10. Okay, the circular coil radius is given as 7 centimeter. It lies in the XY plane. What is the magnetic dipole moment they are asking? So I told you in the previous question, the magnetic dipole moment is also given as what? The product of current and the area. But ಇಲ್ಲಿ n number of turns ಕೊಟ್ಟಿರೋದ್ರಿಂದ n into I into A ಆಗತ್ತೆ. ಹೌದಾ? So n value is 10. Then I value is 5 ampere. Area. So area is not given, but area you can take for the current carrying wire as pi r square. Okay. So n is 10, current is 5, then pi value is 3.142 into radius is given as 7 centimeter. So 7 centimeter andre meter al madಕೊಳ್ಳಿ, 7 into 10 raised to minus 2, it's a square. Check out the answer, what you are getting, and tell me the answer, students. Yes, what is the answer? 10.09. Everybody is getting same. Ten into 5 into 3.142 into 7 into 7. 7 sevens are 49. Just check with your answer how much you are getting. Yes, it is 7697.9 into 10 raised to minus 4 ಆಗತ್ತೆ. Correct? So suppose if you do that divided by 10 raised to 4, the answer is coming out to be 0.769. Magnetic moment it is, ampere meter square is the unit. Just check. 0.77 you can consider approximately. Yes, is it clear, students, all the questions? Okay, so tomorrow we will continue with the last part of the lesson. So very small lesson. I'll upload both the notes today of this chapter and the previous topic. Okay, thank you.